All right. So I should probably say, welcome to, oh no, it's Thursday, February 4th. Oh, there we go. All right. So this was your homework last night, those 2 pages. And you should have already uploaded your first attempts in its proper spot. And now back to what we were doing. The second attempts should be it's my little, there it is. This is what you get if you're vertically challenged like me. Okay, so you should be able to go to, this is where you should have had the first upload done. And now you should be able to go down here and get the answers. Don't upload your problems yet if you didn't fill in number 6. What's the mean and standard deviation? Because I'm going to help you do that if you haven't done that yet. So this was in the helpful homework hints. And in your answer key, I have this, a little bit more. And I honestly don't care how you do this. The math you have on your paper should not let me know if you use Binoprop in the calculator, Binomial PDF or CDF in the calculator, or Binoprop. You could use either one and you'll get the same answer. And I have the printouts of the screen here for Binomial PDF, and then I have what Binoprop would give you at the end. So take a look at that. I know this said to round to the nearest hundredth. If you just have 2 decimal places, that's okay. I will try to make sure on your test it says 4. Why 4, Mrs. Garrett? Well, I think the reason for 4 is because the old tables, back when we didn't have these fancy calculators like you have, the old trig tables and the old, well, you guys have used the old normal curve table, they all have 4 decimal spots. So that's how that kind of got established back in the day. So I would like any questions whatsoever on these 2 worksheets. Yes.
How do you write the like choose part of something that's like between 2 numbers? Like number 5 on page 5.
All right, let's go take a look at it. Like that? Is that what you're asking?
Yeah, but the choose is just 30 choose 2.
Yeah.
Okay.
I'm not sure I understood your question, but did you get it figured out?
Because it says like between 2 and 9.
Oh.
So it's just like, where like do we go when we're trying to like choose how many we want out of the 30? You know what I mean?
Oh, Nate, I got you. So you do it like for each. You do it for each number that you're trying to find, and then you just add them together. That's what the dot is. You just don't write them.
Oh, yeah.
So you do like 30 to choose 2 plus 30 choose 3 plus 30 choose 4.
So he was just asking, like, were you doing these individually?
Well, I didn't do all of them individually. Never mind. Okay, I see what I did. I see what I did.
Okay. As
You
long as
just
you're.
didn't understand how to write it out.
Oh, yeah. You don't have to write out the 3, 4, 5, 6, 7, and 8.
Yeah.
What I have in red down here is not something that you would put in your answer. I just put that to show you what I put in the calculator. If you did it without using Binoprob. But if Binoprob is, I really like Binoprob. The problem with Binoprob is if you get into the coding and mess it up and you don't realize you've gotten into the program and messed it up, then you're not going to get the right answers. And I taught you the other ways because I really want you to understand what Binoprob's doing, and I think we did enough repetitive stuff the other way that you understand, I hope. We'll find out. Anybody, anything, anywhere, now that we figured out what Nathan needed. How's it going, Garrett? You're so quiet compared to like, what? Was it last year or the year before? In honor stat.
I was sophomore.
Okay.
I was pretty quiet in that class.
You had some tomfoolery going on with some of your peeps.
I mostly just played games on my iPad.
Yeah. That was the year back in the days of the iPad.
Yeah, that's
Hudson just went the other way. They just swapped out all their Chromebooks for iPads.
I would
Smart.
use
I would take the iPad.
Okay, but here's the problem with the iPads.
If we had,
The
like,
schools
good
can't
iPads.
afford them. Like Hudson's gonna switch back within a couple of years. Because Ohio State got a grant from Apple to get iPads in people's hands, but it didn't keep coming, if that makes sense. Like Kenston got the grant for 4 years, okay? So we were supplied by that grant money for 4 years with iPads. And then Kenston School District looked and said, oh, we can't ask students and their families to purchase an iPad. So they're too expensive, so we're gonna go Chromebook. Well, Hudson just got the grant because Apple wants to get into the schools. The problem is Apple doesn't understand they're too expensive to sustain. That's, follow the money and you'll figure out what's going on. Yep,
The answer to the second golf question is that's 0.1402.
well, let's take a look.
I can't.
The second one. 0.1402. Yep, not that this is gonna help your version, but. Yep. So it's not terribly surprising, but, there's still a 14% chance. We're gonna learn next chapter or the chapter after that sometime soon, like what becomes surprising. Where's the line in the sand that we go from, this could happen to, something fishy is going on? We'll learn that. Okay, so for number 6, if you didn't do this, the formulas are on your purple paper and we're gonna take a look at those formulas in about 20 minutes. But basically, it's pretty easy for the 30 students. If 20% have math anxiety, we would expect in the long run 6 students to have math anxiety with a give or take of 2.19 students. And even though you can't have 0.19 students, it's an average and a standard deviation, so you give the decimals. So once you put that on your paper, you can take pictures and upload them, and I don't need that worksheet. And someday I will get your 6.3 guided notes graded, I promise. I should have started last night, and I was tired, so I went to sleep at 8:30. What did you do before that, Mrs. Garrett? Well, I was at school until till 3:30. And then I went to Chappaqua to support the junior class, was it?
No,
Sophomores. But I ordered here at 3:37, and so it didn't count. And I tried to call to see if that was gonna happen. But they put you onto this hello, can I help you? Like,
Oh, robot guy.
robot lady. And then I kept saying, live person, please. I want to talk to a live person. I don't want to order online. I want to find out if I put the order in at 3:30 and not pick it up till 4, if it will still count for the sophomore class. Well, they wouldn't give me a live person. It went right to bang, 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 a busy signal, and I called 5 times in a 15-minute period, so I knew it wasn't like somebody else was calling them. So when I picked it up at 4:07 and they told me it didn't count, I was really kind of perturbed. I said, seriously, I tried to call you 5. Our phone never rang. I said, I know, because somebody, like your manager, has it going right to a busy signal. So it's impossible to call you guys. She's like, whoa, I didn't know that.
When you call a number, if you say customer service, like when it picks up, a lot of times those robot guys will like send you straight to the person. I figured that out when trying to figure out my schedule to try and
Customer service.
like if you call and then like before they even start talking, you say that.
Yeah, but I mean, she
customer
eventually
service or
sent me there, but it was not a busy signal. Because I think the Aurora Chipotle doesn't, like
They probably just don't even have their phone set up.
right, something like that. Anyway, she said, well, we'll just apply the code to the next people who order, and then they'll donate for you. I said, that would be a good thing. Here's the form. She knew I was a little sad. We've saved a lot of money during the pandemic because we cook most of our meals at home, which means you have to clean up after yourself too. I have to like plan it out. I have to know on Sunday what I'm gonna cook for the whole week if I'm gonna be in charge of dinners. My husband just can open up the refrigerator and say, oh, pull these things out and throw them in a skillet and suddenly it tastes lovely. That's not me. But he's a much better cook than me, but I can bake pretty well. All right, nobody has any questions on homework? So how's Sophia doing?
Good.
So what are your activities these days?
I have practice for soccer
Ah,
every day, and then I have a ton of homework.
what other classes are you taking?
I'm taking AP Chemistry, AP Spanish, and then this class, and then I'm taking chorus, but like
They don't give homework in chorus? You don't have to?
no.
So how's Mr. Kale behaving in chorus? Is he making it? Or don't you have choir when Stephen has it?
He actually is doing pretty well. His grade likes it.
Oh, good. That's good.
Does he actually sing?
I don't know. I'm not next to him. We're so far apart.
He had to either take choir or art, I
Yeah,
guess.
he walked into art the first day, and he didn't know anyone, and he didn't like it, so he dropped into chorus, and now he says the same thing about chorus. But I'm like, you need your art credit. I just think it's so funny, because chorus and art is not his thing, and it's not fun.
So what other choices did he have? Band?
I mean, no, those really are his only 2 choices, unless he wants to pick up an instrument.
I can't see him doing that either.
Yeah.
All right. So Gary, you have indoor track?
Art one is so much easier.
Yeah.
That one's hard.
Claire has gymnastics. Anything else?
No, I'm actually playing softball.
Nice.
What? You didn't know this?
With Annie
Yeah,
D.
no, I'm just starting this year.
With
Just
Annie
to play
D,
another
huh?
sport. Yeah.
So as long as she keeps that baby inside for a few more months, you'll be good.
Yeah.
She's due in April, so
Yeah, she looks really pregnant.
yeah, she does. That's because she's a tall, thin person, so it just right there. Carson is in hockey, and you must work at Giant Eagle. I'm taking it.
Yeah.
Mr. Peters, what are your activities?
Nothing this season.
That's okay. Staying away from your sister so you don't have to quarantine again.
Ryan's a big Fortnite guy,
Yeah?
for sure.
And,
How about
Yeah.
Ryan?
What about Emma?
work at Giant Eagle, but I'm on it. But honestly, I'm just gonna stay on leave till I get vaccinated at this point.
They'll
There you
vaccinate
go.
You go back. You can get put on the list.
Oh.
For giant eagle work.
If you're under 18, yeah.
They're essential.
If you're under 18, your parents have to.
Vaccinate at least
Oh,
that.
okay.
But like, if you work until
Yeah.
like late and they have doses like this, you're vaccinated.
And I also have a custom homework, so yeah.
That's the.
Nathan? What about you?
I got baseball and basketball.
Ah.
Yeah.
Basketball, but not on the Kenston team,
No, I
because you
got,
weren't part of the quarantine.
we got CYO, and that's a lot more fun to tell you. And then we have rec coming up soon, so that's.
Nice.
Oh, wait, what is Rex?
The signups are already out, but I don't want to coach this year, I just want to play.
Yeah, I'm playing.
That's one thing, I just want to like be put on a team with all your friends, that way you just show up and screw around and drop 60 on someone.
There you go. All right. And you're on the baseball team?
Yeah.
Do you still pronounce 12 as 12? Is that a thing still?
What?
Okay, never mind then. When the Casaro brothers, all three of them played, there was something with the number 12. They all pronounced it 12, like you didn't put the on the end. So every time in class we had the number 12, we all said 12.
12?
12.
I mean,
11, 12.
I guess if we're like rattling stuff off in the dugout, but I don't.
It must not be a
I don't
thing
say
anymore.
12, that's just weird. That's just stupid. If it, yeah.
I mean,
Well-
you sound pretty cool, right?
Do I?
A
Saying.
little bit, yes.
And how about Miss Salem? What's your life involving?
Like work.
And you work?
I work at Jenny's, like the ice cream shop.
Ah,
Yeah.
my husband likes that Cajun chocolate stuff.
Yeah, we don't have that right now.
Yeah.
So a lot of people ask for it.
Hmm.
Everybody just asks for everything we don't have.
There you go.
I don't
That's
understand
like
how
one of
people
my
do that
favorite
in high school.
Grater's flavors was that something cheese flavor. It sounds bad with ice cream, but boy was it good with
We have like
apple
goat
pie.
cheese on. We
Do
have
you?
goat cheese with cherries. Yeah, we just got it back today, actually.
Is it good?
Yeah, people are like obsessed with it.
Did you try it?
It's pretty good. It's like kind of like cream cheese. I don't really know what goat cheese is like, but it's fine. I don't love it.
Mitchell's has a strawberry chocolate chunk just for Valentine's Day.
Yep.
My favorite is coffee chocolate chunk, and I don't know how they make those chocolate chunks be so uncrunchy, like they're fudgy. That's a game changer.
Do you get a warm brownie in the cup?
Ooh, I've not tried that.
If you get a warm brownie, oh my god, it's game changer.
I can make a serious brownie.
Really?
All you need is Ghirardelli double chocolate.
Yes, that's the best one.
Why try anything else? Use Ghirardelli.
Homemade are always worse than somehow.
Yeah, I agree. And what about Miss Alina? What's up with you?
Well, I use this one that I flipped, and I'm not really doing
I'm not very good at breathing right while I swim. But swimming wasn't a thing. It was only a summer thing when I grew up. But what other classes are you taking right now?
I'm doing
All right. Okay. My life involves making sure my dad's okay when I get home and grading papers and being ready for the next day. And I can't wait for the snow to go away and the earth to warm up so I can go outside again and walk at least. Maybe pretend to jog. But get the boat back in the water. Speaking of which, I found out yesterday that most of you guys don't know about the really cool waterfall that is on Kenston School District property.
There's a waterfall.
A really cool one down by Centerville Mills. And I guess you don't know about it because now the Cascades own it, like that row of fancy homes right by 306. And it says no trespassing, so you guys haven't trespassed, so that's good to know.
Well, it's nice.
But do you know where the Centerville Mills is? It used to be a YMCA, it used to be a summer camp. It's right by 306. before you go down the hill and then up the hill to Treat Road, like heading towards Aurora. Everybody know where I'm at? It's like the far corner of the southeast part of this school district. Yeah, there's an awesome waterfall there. You can walk behind it. Huh?
Isn't that park just a big field?
Yes, but there's a little bridge that you go over that connects, like there's a pond, but there's also a river right before the pond. And you go over a tiny bridge and the river goes underneath you. And I forget how we started talking about this yesterday for a vlog, but, and if you go there, don't tell them Mrs. Garrett told you to trespass, because I'm not telling you to trespass. I'm just telling you it's an amazing waterfall. People used to get their senior pictures taken there all the time.
Oh, it was the first thing you showed.
It's not any of those.
Yes.
Huh?
You going to last time?
No, it's not any of these.
Doesn't it have an old building by it though?
There it is. That's it. I mean, it's pretty big. That's the one Centerville Mills building. You cannot see this from the road. There is a house right up there, a greenhouse. But you can walk right behind there.
Have you been to the waterfalls on the Michigan River? Like, have you like ever walked down the Michigan River and like at a certain point there's like waterfalls that people jump off of? Not the big falls, obviously, but like, yes, those are fun.
You mean in Chagrin Falls.
Like yeah.
And you walk like up above it or down below.
I think it's down below, because then there's also like a rock formation, like, and it's like you can take tubes there, because like the rock is out, but like water and moss covers it, so you can just slide down the rocks. And then if you just take your tube down the river, you come on on a triple layer waterfall with like 3 different layers that you can jump off of, with like caves inside of it.
I have not been there.
It's pretty cool.
I haven't. But yeah, this is pretty. There used to be obviously something here, but right on this side are all those fancy homes on Cascade Road or something it's called. I guess that's what it looks like behind it. All right then. Okay. So today we're going to continue this, but we're going to talk about this whole at least one problem and what to do about it and how we handle that. So this is on page 7 of your packet. I'm going to turn on the light again, so watch your eyeballs. All right. So let's just get through this, and hopefully you will understand why it's important to do a 1 minus thing sometimes. Since approximately 30% of calls to airline reservation phone lines result in a reservation actually being made, so 70% of them are just people calling and asking questions about the flights. Suppose that an operator handles 5 calls. Assume the 5 calls are independent events, meaning they didn't come from the same person over and over and over again. What is the probability that none of the 5 results in a reservation? So let's set up, right now the probability of a reservation is 0.30. So what is the probability of a reservation not? Complements are always 1 minus, right? So that's 0.7. And we want 5 calls. So this is doing it a little bit different than using the binomial formula. This is just thinking about it. If we want no reservations, then basically we want 0.7 to the 5th power, and that happens to be 0.1681. So there's a 16% chance that this operator is going to get 5 calls in a row and nobody will make a plane reservation. Nobody will book a flight. That's what I'm trying to say. All right, what would that look like if we use our probability notation? It would look like this. The probability that x equals 0 would be 5 choose 0 of 0.3 to the 0, 0.7 to the 5th. And I think you can see how that is exactly what I have up there in blue. Because 5 choose 0 is 1, 3 to the 0 power, anything, 0.3 to the 0 power, anything to the 0 power is 1. So it's basically just 0.7 to the 5th power, or 1681. All right? Now, what is the probability exactly 1 of the 5 calls results in a reservation? Well, let's take a look at all the different ways we can do that. We could have no reservation, no reservation, no reservation, no reservation. The last call is the reservation, right? Or we could move that R up 1. Or we could move it up to the middle. There's basically 5 ways to have 5 calls, and only 1 of the calls is a reservation. This right here is 5 choose 1. Right? And 5 choose 1 is 5. So we're going to have 5 times 1 reservation, so the other ones are not a reservation. Because you have 1.3 and the other 4 ends are the 0.7. And that happens to result in 0.3602. So you can see that it got much more complicated when we went from no reservations to just 1 reservation. Exactly 2 reservations. Well, let's write out this sample space. How many things are in this sample space? We could have reservation. Whoops, wait a second, I gotta get a thin pen again. Reservation, reservation, not. All right, Ryan, what else could we do?
Not. Reservation.
Okay. Carson, give us another one.
Reservation, not. Reservation.
Sophia?
Not reservation, not reservation.
All right, so far that's 4. Claire?
Reservation, not reservation.
Is that what you said? Or did you have the 3 ends in the middle?
I have the 3 ends in the middle, but it doesn't really matter.
I know, so we'll do yours. Okay. Garrett, what are we missing?
Not reservation, not.
Okay. Emma?
Not reservation, not reservation.
I don't think we have that one yet. Nope. Nathan?
Not reservation, not reservation. Wait, yeah, and then reservation, not.
Okay. Alina, can you think of one we don't have?
Reservation, not
Not? Well, we have that one there. But we don't have it if we switch those two, right? Okay, so we're gonna switch those two. So I'm hoping right now you're starting to feel the issue. We actually have more left. Nope, we have one more left. How do I know that? Because 5 choose 2, which is 5 over 2, is 5 times 4 over 2 times 1, and that simplifies down to 5 times 2, which is 10, and I have 9 right now. So what one are we missing?
Not reservation,
Not reservation, not reservation. I believe you're correct. So there's 10 of these, which is 5 choose 2. And so there are 2 reservations. 0.3 to the second, 0.7 to the third. And that's going to be 10 times 0.09 times something. Let's just use our calculators. And I'm going to skip you having to go to the calculator. It's 0.3087. Jeez. So we've done no reservation, 1 reservation, 2 reservations. Now it's up to 3 reservations.
How did you know that the 5 choose 2 would have like 10?
Because if you work out 5 choose 2 in your calculator, it's 10.
Oh, okay.
And I did it in my head here because my shortcut is take 5 out 2 places divided by 2 factorial. So that's 20 divided by 2, which gives me 10. Yeah, I just knew that from doing it for a long time. All right, so that's exactly 2 reservations. And now we're going to go to exactly 3 reservations. Let's just talk about that. I don't think you have that on your paper, right? Exactly 3 reservations would be the probability that x equals 3 is 5 choose 3, which is 5 times 4 times 3 over 3 times 2 times 1. So guess what that's going to be? Also 10, right? Okay, so that's 5 choose 3 at 0.3 to the third, 0.7 to the second, and that is actually 0.1323. Okay, so that's for 3 reservations. Let's do 4 reservations. The probability of 4 reservations is 5 choose 4 times 0.3 to the fourth times 0.7 to the first. And we could write out, there's 5 of those, because it's just the opposite, I hope you get, of this. And 5 choose exactly 3 is just switch all the N's and R's here. So I picked 5 because it gives us enough for you guys to get the idea that this thing blows up really quickly. That's what I'm trying to get you to realize. And if you do that, it's 0.0284. All right, what if all 5 calls result in a reservation? Well, I think that's the easiest case because it's really just going to be 0.3 to the 5th power, right? But if you use a binomial probability formula, 5 choose all 5, 0.3 to the 5th, 0.7 to the second, turning to the 0 power, we know that's a 1 and we know this is a 1, so it's easier to think about than using the formula. And 0.3 to the 5th power turns out to be 0.00243. Okay? So, whenever you're asked this question, which we're getting to now, What is the probability that at least one of the 5 calls results in a reservation? Basically, if you want to do it the forwards way, you have to go back and find 1, 2, 3, 4, and 5, and add those all up, right? But it's actually easier if you just do what? 1 minus no reservations. So, let's talk about that. Or let's make sure we understand that. So, at least 1, the probability that x is greater than or equal to 1 is equal to the probability that x equals 1 plus x equals 2 plus x equals 3 plus x equals 4 plus x equals 5. And what was our probability of x equal 1? 0.3602? All right. So we need a couple of you to add these up for us in our calculator. We'll take Garrett and Alina and Nathan. You 3 be adding up these decimals that I'm writing down here. Exactly 2 was 0.3087. Exactly 3 was 0.1323. Exactly 4 was 0.0284. And exactly 5 was 0.00243. And we need to know what that total is. All right, I'll randomly decide one of you. Nathan, what'd you get?
0.83203.
Do the other 2 agree with him? Alina and Garrett? Okay. And I believe I agree with that also. So that's the hard way to do at least 1. And sometimes it could take you all day, because what if we had 20? What if we had 20 people calling with the same amount? To do at exactly 1 of 20, exactly 2 of 20, exactly 3 of 20, 18 of 20, 19 of 20, 20 of 20. To go through all that would take you a long, long time. So let's do this as 1 minus the probability of none. Because that's the only piece that's missing in here, right? So this would be 1 minus 0 point, and what did we get for none? 1681. All right, so if Claire and, that was the wrong cup. Claire and Emma Salem, both of you do 1 minus 0.1681. Tell us what you get.
0.8319.
Okay, do you see how those are basically the same? Why aren't they identically the same? Because I rounded all of those to 4 places. That's why. Okay, so let's use this now to do some problems. And now, if you would have known this way back when we started doing the multiple choice questions and probability, chapter 5 and chapter 6, you'd be like, oh, that's why whenever you see the words at least 1, so let's put that down here in the conclusion. The conclusion I want you to make is this. If the words at least 1 appear, think 1 minus none. So the probability of at least 1 equals 1 minus none. That's the shortcut that you have to remember. So you guys try those last two questions now. See what you get for the answers. Same thing, 30% chance of making an actual plane, buying a plane ticket, and you handle 10 calls. So first question is, what's the probability that none of them? And then what's the probability at least one? Oh, I need to check my attendance.
Yep.
All right. I looked at it this morning. I just didn't press save. So I need to now take attendance for the day. I have caved. And now I am a bad teacher and I take it ahead of time. So I don't have a messenger at my door. I do usually look and make sure, but. All right, everybody's back in the hat here. Or cup, I guess it would be. I don't know what those are. All right. Miss Salem, what did you get for none?
0.0282.
Everybody agree with her? What would that look like if it were notation? It would be 10 to 0 of 0.3 to the 0, 0.7 to the 10th. And then for this one, I'm just going to do 1 minus 0.0282, right? That's the shortcut. So when you do that shortcut, Mr. Gaskins, what did you get?
0.9718.
Everybody agree with him? Now, if you recognize that this is actually a binomial distribution situation, you could just do binoprob. You could do 1 minus, or I'm sorry, you could just do this. Right? And I could plug that in my calculator's binoprob program. Probability of success is 0.3. I have 10 people calling me. I want 1 to 10. That's pretty much the same answer if you round. So why did I even bother going through this whole sheet with you? Here's why. When you see these problems in a multiple choice situation, are you going to take the time to go through bins to make sure it's perfectly binomial? To then know you could put it in binoprob? No. And if it tells you there's like 200 calls being made, that might not be able to be handled in your calculator. Eventually your calculator gets to the point where it doesn't have enough active RAM to be able to calculate things for you. All right, so let's try these problems on the back page. This one you actually had as a multiple choice problem. Does anybody remember it? She talked about blood types. That was last week or the week before, I think we did it. And I promised you we'd get to the point where I'd explain why we do the shortcut. People with type O negative blood are universal donors. That is, any patient can receive a transfusion of O negative blood. Only 7.2 of the American population have O negative blood. If we choose 10 Americans at random who gave blood, what is the probability that at least one of them is a universal donor? So as soon as I see that phrase, at least one, I think to myself, 1 minus none. So 1 minus no universal donors, and we have 10 of them, right? So I'm going to do, okay, not O negative would be 1 minus 0.072, which is 0.937, I think it was. Is that right? Nope. 928. I had yep. So I want 1 minus 0.928 to the 10th power is how we would solve that one. So you're kind of doing the law of complements twice. Point 5263. All right, so try the one below it because we have not done this one. The internet, I don't think this has been a multiple choice question. All right, Claire, do you know what I'm going to put to figure that out?
Yeah, you're gonna find, what the probability of one is, which is 0.8777, which is 0.3773, and then you're gonna subtract that.
I think that's what you said, right?
No, 0.37.
0.3773?
Yeah.
And so what do you get?
On 0.6227.
Yep, very good. So you have to remember when I see the phrase at least one what to do. All right, it's time for us to move because we're all getting sleepy. Because I know this is like just such exciting stuff for you. All right, so I have prizes. If Dee Kramer hasn't eaten them all yet, now that she knows they're here, she's usually listening to us, so that's why I mentioned her. All right. I have, you can have a small cup of M&Ms, like not filled up, but like maybe like half filled. Swedish fish, you can have 3. Reese's Cup, Kit Kat, or 3 Starbursts. I have the Swedish fish and the Starburst because I have a couple people who are lactose intolerant. So that gives them something other than chocolate. But thankfully, I have nobody that has told me that they're allergic to nuts, so. All right. So, I can either choose or I can randomly have the calculator choose and let me know. We're gonna play the corners, that's yellow. That will be corner 2, that's corner 1, that's green. Corner 3 is up here, it's blue. You can see because I have this blue guy right here. And then that's corner 4 and that's red. So do you want me to choose by calculator or by my own brain? Calculator? Okay. So it's gonna go fast. So you have to like move it. So you guys, this is how I'll do it by calculator. I will do math, probability, random int, and I will generate an integer between 1 and 4. So that's 1, 2, 3, 4. Okay, let's see who's out. Sit down. You 3 are out. Okay, ready? I'm gonna say 5, 4, 3, 2, 1, and we're going until there's 3 people left. 5, 4, 3, 2, 1. 4.
No.
Ready? 5, 4, 3, 2, 1. 2. So there's 3 people left. What do you guys want? Oh, yeah. You too. Okay.
Mrs. Garrett,
Alright,
did
so
Cooper just not show up this
I
morning?
just.
Huh?
Is Cooper not here today?
Yeah, he's already over there.
Oh, okay.
Is that all just done?
I can get you 4, 3 to 6.
I think I'm gonna go yes.
Oh, wow.
Thank you.
All right, let's go again. Ready?
Holy crap.
Yes.
Ready?
Cooper's shield is so much cleaner.
Who's?
Cooper's, I traded our shield. Mine's all dirty.
How are you?
Old dirty boy.
Ready?
His dirty
You
shield.
guys set. All right, ready? 5, 4, 3, 2, 1. At least 3. What do you guys want?
so easy.
Mark.
That was-
I'll take Starburst.
That was dumb.
You can have, what did I say? You can have 4 AC. What do you want?
Don't take all 3 pink ones, dude.
Well, there's more in the bag.
No.
What do you want? Well, we're gonna play one more time.
No, we're playing a third round.
Yep. What, do you have your cup? There you go. All right, ready? Here we go. 5, 4, 3, 2, 1.
Have they ever chosen 1 or 3?
You guys wanted me to use a calculator.
It's been 2 and 4. Scroll up. It's been 2 and 4 every
Well, then
time.
don't pick 2 and
Then why'd
4.
you go to 2 and 4?
Because I got
Ready?
ready. 5, 4, 3, 2, 1.
Oh my God.
This is one?
Garrett, I told you I was getting
One,
sussed out
two,
when you didn't leave.
So there's only 3 of you left. Alina, you guys need to follow Alina because so far she has won every time.
That's because she's
Okay, but let's go.
Okay, you guys
That's still 3.
win. Ryan, aren't you? Is there
I am.
3 left?
Ryan's getting his cup.
You want more fish? Okay.
We'll just skip one and start from time to back. Oh, not a yellow.
There's 3. You want one more? Okay, what do you want?
I'll take some sweet apples.
I'm cutting out on carbon
Oops,
anyway.
that's yours. All right, who did not win? Who didn't win?
I didn't win.
Come up if you didn't win.
No, that's not how
Go catch
losing
yourself.
works.
You get pity prizes.
That's not how losing works. You
Not
work
a kid.
Garrett, go catch yourself.
I'm going Reese's.
Garrett?
That's big cat. Thank you.
Everybody will do Reese's, please.
Yep.
But that's.
I the best Reese's product is the Reese egg,
Yes.
because it is the perfect peanut to chocolate ratio. I'm just saying.
You know what's also really addictive? Is when they come out with a mini cup for like Christmas time. Because then you just eat them, you eat like 20.
Yes, notice I got the snack size and not the fun size because I don't know who named the fun size, but the fun size products are like this big.
They're not very common.
No, they're not. They're definitely a misleading, biased name. Okay. So we are now on page 9. And you get the joy of learning how these binomial formulas came into being, because this is not just honors, this is advanced placement. So how the heck did these two formulas come from the top times the bottom stuff? Because this is a special case of probability distribution. So in binomial, you have winners and losers, as we do in the four corners game. So you can have be a loser or a winner, right? And what do we call the probability of success? What letter do we give that? P. So this is the probability of P, and this is 1 minus P. Correct? So now if I do mu sub x, what's the expected value of this? It's 0 times 1 minus P plus 1 times P, and that equals, well, this just goes away, that equals P, right? All right? That's the probability. But if we have 10 trials, then we would have P added to itself how many times? 10. So in binomial, if you have n outcomes, you can see how if you add n p's together, how many is n? I don't know, but if we add n p's together, doesn't this become n times p? That's how we get the mean of a binomial distribution. So that wasn't too many brain cells that we lost there. All right, let's go back up here and let's do the standard deviation. Well, if the mean is p, and I take that up above, then the standard deviation is going to be, I was going to say, are people leaving class already? Like, that's 20 minutes early. It's driving me crazy. I'm like, we can't be done with class yet. I have more to do. I don't know. There's a lot of people out in the hallway, but I'm assuming they're not done with
Yeah,
class.
they're taking a break.
Mrs. Smith dismissed her class early one day.
I almost dismissed last block yesterday at 1:45. Well, because at 1:45, the shorthand's over by the 2, and I was like, oh my gosh, class is over. Did I really spend like 40 minutes talking about Centerville Mills? And then I gathered myself, and I'm like, oh, the 2 hands aren't over there, just the 1 hand. I'm okay, I got 20 minutes. Okay, so what do? We do 0 minus p, the quantity squared, times its probability, plus 1 minus the mean squared times its probability. Right? Okay, so this just becomes negative p to the 2nd power, which is p squared. And this becomes p times 1 minus p quantity squared. I just switched that around, right? All right, well, do you see that they have this factor in common? So I'm going to take one of those out front. I'm going to undistribute. And that leaves me with p squared plus p times 1 minus p, because I can only take one of those, right? So this should be feeling like Algebra 2 class. So now I have 1 minus p times p squared plus p minus p squared. Look what happens to the p squareds. They add to 0. They're called additive identities of each other. in case you wanted to remember that term. So these two, add the 0, and now I'm down to 1 minus p times p, which looks incredibly like the formula I'm after. It's n times p times 1 minus p, right? Well, what you have to remember is this is actually a variance, right? Because I haven't taken the square root yet. And just like up above, if you have n of these trials, guess how many of these you'll have? N. So now we see where the NP, 1 minus p, comes from. But remember, that is a variance, so what do you have to do to get to the standard deviation? You got to square root it. So that's where those formulas come from, the shortcut formulas for binomials. They actually didn't just magically appear. They do have a derivation. All right, well, that was fun, Mrs. Garrett. Yes, it was. Okay, let's see if we can use our knowledge now. And then I'm going to teach you geometric, and I think geometric is so much more instinctive than binomial. I don't even like the geometric formulas. I think you can do it just by instinct a lot better, but we'll see how you feel about that. Oh, let's go back to our other packet. This packet now, remember doing this? We got to here 2 days ago. And I think we also graphed that graph on the back. So that's the other packet. The packet that we almost finished. It's the packet with the M&Ms. Didn't we get that first one graphed?
Yeah.
Okay, so we're going back to this front page because we know how to do this now. We don't have to write it all out like that. We have a binomial formula for this. And if you remember, 0.27 was the chance you get somebody who was born outside of the United States, called foreign-born, and it's just kind of fun to say. And 73 was the chance that they were born in the United States, that's domestic. So what would I put in for this formula? 3 choose 0, a 0.27 to the 0, a 0.73 to the third. So if X is representing the number of foreigners, the only way I can get 0 foreigners, and I don't have to do that in my calculator, which number is it on my table? 0.389017, right? So let's just put 0.38, well, we can fit it all in there. And then the next one would be 3 choose 1, 0.27 to the first, 0.73 to the second. Are those formulas like, can you write that out now without thinking too much about it, I'm hoping? So we're writing these out ad nauseum for a reason. Like I'm hoping it gets stuck in there. Now, it's what 3 added up. 1 foreigner is these 3 added up, the 14's added up, but we already did that. Down below, it's the 0.431649. And I think you can see where we're heading with this. 3 get 2 foreigners, 0.27 to the second, 0.73 to the first. And that's going to be the 159, 651. And then the chance that they're all foreign-born is 0.019683. And that is not the right order, Mrs. Garrett. And guess what those all add up to? Yep. 1. All right. The next thing we did is we multiplied out the top times the bottom the long way. So let's prove that it works with our new calculations. What's my n? How many people am I taking? 3. And what's the probability of being foreign born? 0.27. And if we work that out in our calculator, 3 times 0.27, I end up with 0.81, and guess what? That is exactly what I got when I did it the long way. And now for the standard deviation, just making sure we believe this, it's the square root of 3 times 0.27 times 0.73. And if I do that in my calculator, square root, 3 times 0.27 times 0.73, I get 0.76896, which is 0.7690 if I round it properly, and that's the same thing that I got here. All right. One more thing we're going to do before we finish the other graph. And that is we're going to take, we're going to take this that you have on page 20, and underneath it put a C, parentheses, X, and we're going to accumulate. So the first one down is the same as the top one, and then we add the 0.3890 to the 0.4317 and get that. And then add that to the 0.1596, and then add this to the to the 0.0197, and that should add up to 1. And so now we're going to draw in the cumulative relative histogram of the probabilities. And so this is going to be the cumulative number of foreign borns. So 0 still goes up to the 0.83. I'm sorry, to the 0.38. So that bar is exactly the same as the bar on the graph up above. 1 goes up to 0.82. 2 goes up to 0.98. And 3 goes up to 1. And whenever you do cumulative graphs, they're always going to be less skewed because you're always totaling your bars up to the number 1. So they're always going to be skewed to the left. And the last bar is going to go up to 1. Okay. We are done with showing how that equals. So now back to the other packet on page 10. And I think we're actually going to skip 10 and go right to page 11, to geometric. Because I want to teach you geometric before tomorrow. All right. On the back side of that one purple page that we had, we have geometric. Geometric is very similar to binomial, except for you have to keep going until. So the key word for geometric is until. And you have this formula, which I honestly believe is a waste of time. And then we have the mean and the variance, which makes the standard deviation equal to this. And then this one is one that we might have to think a little bit about. So let's do the top of page 11. In each setting, do we have binomial, geometric, or nothing? Flip a coin until you observe a tail. Do we have two outcomes? Yep, heads or tails. Do we have fixed or indefinite? The word is until there is so you don't know how long you're going to have to flip this coin, so it's indefinite. Independent trials. Does the coin tell itself what it just did? So it's totally random, even though the word random isn't there. And what is the probability of getting heads or tails when you flip it? 0.5. So this is geometric. It is exactly the same except for number 2. The n, we don't know n, we go until something occurs. All right. I think I want to go down to the number, example 4. There are 10 red marbles and 5 blue marbles in a jar. You reach in and without looking select a marble. You want to know how many marbles you will have to draw without replacement on average in order to be sure you have 3 red marbles. So, do we have 2 outcomes? Yeah, it's either red or not red, right? Which is just blue here. Do we know how many we'll have to keep pulling out until we get 3 red ones? So we have indefinite, and that's good. Are the trials independent?
No.
Because we're not doing what?
Replacing?
We're not replacing it. So the first time I have a 10 out of 15 chance. The first time I have a 10 out of 15 chance. But then, if I get a red one, it goes down to 9 out of 14, and if I don't get a red one, it's 10 out of 14. So the probability changes, correct? So the trials are not independent. And is the P the same for all trials? No. So this is neither. That's not geometric and it's not binomial. What if I replace it after each time I pull it out? Then it is independent trials, assuming you shake it up real well and you don't just drop it back in the top. And the p-value would be 10/15, which is what, 2/5? Nope, 2/3. 2/3. 5 goes into 10 twice and into 15 3 times. So if we had replacement, then we could say that it would work. All right, so let's just go through those few examples that are on page 11. What is the probability it takes 7 times until you roll a number 6? This is why I don't like this formula. If I have a fair die, what's the probability that I roll? Well, rolling the number 6 occurs over here, right? On trial number 7, and there's a 1/6 chance. So on all the things before that, I don't want the 6. So how many ways are there not getting the 6? 5, 6. I have to get not a 6 times, right? That's where this comes in. This would be 5, 6 to the 6th power times the final winner of 1/6. I like just putting out the lines and figuring it out without having to worry about a formula. All right, next problem. Draw a card from a deck of 52 cards, observe the card and replace it. Shuffle it really well. What is the probability that a jack is drawn on the fourth draw? How many jacks are there in the deck? 4 out of 52. So that's the one I want the jack to occur on. So how many cards are not jacks? 48, and I need that to happen the first 3 times. I don't want a jack the first 3 draws. And then, see, then I can say, oh, I'm just going to put 48 divided by 52 to the 3rd power in my calculator times 4 divided by 52. All right, just 2 more. These are the formulas. Actually, I think, take out that purple sheet. What is the formula that you have? On the back side of the 6.3 purple sheet. Here is my purple sheet. On the back side of this. I have it written out as a standard deviation for you, right? So I have this. The standard deviation, which would be sigma sub x, is the square root of 1 minus p over p. All right. So we're going to calculate that. How many times would we expect to roll the die until we observe a 3? Well, that's 1 divided by what's the probability of getting a 3 on a fair die? 1/6, right? So that answer is just 6. And what's the variance? Or let's change this to what's the standard deviation. So scribble out that and let's put standard deviation. And the formula for that on our pink sheet would be the square root of 1 minus 1/6 divided by 1/6. And whenever you have fractions, what do? You have to flip it and multiply, invert the bottom and multiply. So this is going to be 6 times the square root of 5/6 actually, when you subtract 1 minus 1/6. And so that is going to be 6 times the square root of 5 divided by 6. And I get 5.477. So you should get it on the 6th roll, but it might take all the way up till the 11th roll, or maybe you'll get it all the way on the 1st roll. Anything between the 1st and 11th would be not suspicious. All right. Your homework is the following. The Brontosaurus problem is an actual AP question. And C and D of the Brontosaurus might be a little bit tricky. And then those other problems are out of your book, but I put them on worksheets, so you shouldn't have to do a worksheet. Some of them are very similar to yesterday, and some of them use what we went over today. But I still don't think it will take you that long. And these are the optional test review pages.
Are those multiple choice questions that we have to do as well?
Yeah, but they're on the paper for you. You don't need your book. All right, kiddos, have a good one. Am I supposed to tell him what you did?
Oh, no, yes, God knows.
Coop, you're holding my shield. I don't know really.
He switched you.
Yeah, he doesn't care. You
Because
actually have
his shield-
Velcro now. You're supposed together. Yeah, exactly. It's a fair gift.
Well, I have Velcro that you can have for his. Do you
I'll
want a
probably
piece?
eventually put Velcro. I'll see what it's like to live in Taylor.
Okay,
I'll see you tomorrow, Miss Garrett.
see you guys tomorrow.
I need to get off on time.
Do you want a piece or two?
Oh, yes, please.
I have them right here. Except for these look like they're all, okay. So this
Thank
is-
you.
This is,
Thank you.
yep. That way it won't fly open as much. I have more Velcro too, I just don't have it cut up. So I think these are all pieces of, that don't stick together now. Is that the nice one on the wall? Yep.
Oh,
It's not that much. They're all on worksheets.
it is a lot.
Oh, wow.
It's more than I wanted to say that.
Bye, thank you.
You're welcome. That's because you never want to do any of it. So, true?
Yeah, I'm not gonna deny that.
I heard that you're gonna have homework in choir today, so
Bro,
that's what I heard.
better not.
That's what Sophia told me. She said, yeah. There's a couple nights that she gives us homework, and tonight's one of them.
Yeah, they didn't give me a lot of stats homework.
That's not a lot. It's really not that much. There's 4 questions on the first worksheet, and those are multiple choice at the end, and the other questions, you can probably have them done before you leave this room.
I bet.
So what about Leah? Do we know about Leah? As of right now, it says that Leah's gonna be here.
Amelia, is it day 3 schedule?
Yes.
Okay. But she's not posting it though.
Oh, yeah.
Like, I don't mind you not posting the whole thing, just say what day.
Oh, I have to stop the,
Takes me a